Welcome to the Sleepy Cosmos channel, a place where science and serenity meet. Here we explore the quiet wonders of the universe, from dark matter to string theory, all told in a calm, soothing rhythm designed to help you relax, drift, and dream among the stars. Each video is a guided journey through the cosmos, slow, meditative, and filled with real science wrapped in gentle storytelling. So if you love space, curiosity, and the peaceful side of knowledge, you're in the right place. Make sure to subscribe for more new sleep narrations every week. And if you'd like to reach out for collaborations or business inquiries, you can contact us at the sleepycosmoschannel@gmail.com. Now, settle in, take a deep breath, and let's drift into the universe together. Tonight, you are invited to drift into one of the quietest ideas in all of physics, the idea of going inside a black hole, not with urgency and not with danger, but with the soft curiosity of someone letting their thoughts wander through deep space. You are not here to solve anything, and there is nothing to understand perfectly. You are simply here to rest inside a question. What would it feel like to cross the horizon of a black hole and continue inward, slowly, peacefully, as the structure of space-time reshapes around you? Just thinking about this already changes the rhythm of the mind. There is something calming about imagining a boundary where light can no longer escape, a place where gravity becomes geometry, and where the rules we know begin to soften at the edges. You can let the idea unfold gently, like a distant star dimming behind a cloud of dust, fading into quiet. Physics can be a guide. But it will follow you at your pace, never demanding effort, never asking for precision, only offering a calm, steady description of what is known and what remains mysterious. Let your breathing settle into a slow drift as your thoughts approach the shape of a horizon. A horizon is not a wall, not a surface, and not a barrier. It is simply a region where the paths that light usually takes curve inward instead of outward. It is a place where the geometry of space-time folds a little more tightly, like fabric gathering toward a point. Even imagining that can feel like floating. A black hole is often imagined as violent, but the reality depends on its mass, and the most massive ones, the giants at the centers of galaxies, have horizons so vast, so gently curved at the outer edges, that you could drift through them without feeling anything unusual. No sudden shift, no sensation of falling faster, no sharp tug, just a continuation of whatever motion you already had, as if the universe were a calm river carrying you forward. Inside this introduction, you can let your curiosity move with that river. Inside a black hole is a phrase that feels dramatic, but its meaning is quiet, almost abstract. To be inside is simply to be in a region where every possible path points inward, not because you are being forced, but because the geometry allows no other direction. It is not a trap in the ordinary sense. It is a place where space-time itself flows, like a gentle current. Allow that image to soften in your mind. No struggle, no resistance, just a slow drift into deeper curvature. Some people imagine a black hole as a void, but physics describes something more structured, more intricate, and surprisingly elegant. The curvature strengthens gradually, like gravity becoming more focused, more concentrated as you approach the center. Nothing about this needs to feel frightening, because this journey is only an idea, a calm exploration of geometry, not of danger. You are not falling toward destruction. You are drifting through a landscape shaped by equations, equations that continue to whisper their meaning even where our understanding fades. In the space of your imagination, you can approach a horizon without fear. You can cross it effortlessly, as easily as moving through a shadow. The horizon is where light becomes quiet, where time bends differently for different observers, where the outside universe seems to slow down from your perspective. But inside yourself, inside your own frame of reference, everything feels ordinary. You remain weightless, you remain calm, you remain carried by the same motion. There is something soothing about this. The idea that even in the most extreme places in the cosmos, physics behaves gently for the traveler. The harshness often belongs to the story told from the outside, not the experience from within. This is one of the first concepts to settle into your thoughts tonight. The difference between outside and inside, between the view from afar and the view from the path you take yourself. From far away, A black hole seems like an edge of time, a point where clocks appear to slow almost to stillness. But for you, moving inward, your own time flows naturally, smoothly, without distortion. This contrast can feel like a quiet paradox, a reminder that the universe looks different depending on where you stand, or how you move, or how space-time curves around you. Let that idea rest softly in your mind. The same event, the same place, the same motion, can feel completely different depending on perspective. It is a calming thought, one that opens space for acceptance and for letting go. You do not need to grasp all the details. You can let the details drift in and out, like stars passing behind a gentle fog. The purpose of this journey is not to memorize physics, but to rest inside its quietness. Black holes offer one of the calmest landscapes in theoretical physics, not because they are simple, but because they are complete, sealed from the outside, self-contained, and governed by the pure curvature of space-time. Every motion leads inward, every path curves softly, every beam of light turns the same direction. There is a sense of inevitability, but it is not a harsh inevitability. It is simply the mathematics of curvature, the way a river always flows downstream, the way a planet orbits, the way a leaf drifts in a breeze. In this introduction, you can imagine yourself at the very edge, just above the horizon, floating gently, approaching a region where the behavior of space changes. The universe outside remains bright, distant stars still shine, but their light seems slowed, slightly stretched, slightly dimmed. You feel a quiet shift, a soft deepening of gravity, a sense that time, space, and direction are folding into something new. But nothing is forcing you. You are simply drifting, and the horizon waits without urgency. A horizon has no thickness, no surface, no texture. It is only a boundary in the geometry of space-time, a threshold defined by the paths that light can follow. As you move toward it in your thoughts, you can imagine gravity not as a force pulling you, but as a slope in the structure of space. A slope you do not climb or fall down, but simply glide along. The closer you get, the quieter the universe feels, as if external noise fades and only your motion remains. Physics describes this motion clearly and calmly. Once you cross the horizon, the inward direction becomes part of time itself, a dimension that cannot be reversed. But in your experience, this feels no different from any ordinary moment passing. Every second carries you further inward, the way every second of daily life carries you forward in time. This idea, that inside a black hole, moving inward is as natural as moving forward in time, can be one of the most peaceful thoughts of all. It means that you do not need to push or resist or struggle. You simply continue. Your proper time moves with you, your path curves with the geometry, and the universe flows around you. In this gentle state, your mind does not need to decide anything. It only needs to drift with the thought. Black holes are some of the most mathematically elegant objects ever described, perfect in their simplicity, defined only by mass, spin, and charge. All complexities fall away, and only pure curvature remains. A black hole is the ultimate expression of gravity, gravity shaped into a closed world, gravity that bends space until space becomes a direction of descent. Imagining this can feel strangely soothing, like tracing a smooth spiral with your thoughts, a spiral that deepens not through danger, but through geometry. As the introduction comes to a close, you can let yourself drift with the idea that entering a black hole, in imagination, is less like falling and more like sinking slowly into a deeper form of space, a quieter form, a darker form, a place where the outside universe fades into a soft glow. And here, floating at the edge, you are ready to cross the horizon, calmly, curiously, without fear. Let the thought settle. You are safe, you are drifting, and the journey inward is about to begin. As you drift toward the horizon, the universe around you begins to feel quieter, not because sound has changed and not because anything physical has shifted, but because the horizon represents a change in the structure of space itself, a change so smooth, so continuous, that you would not feel a boundary, and yet you would sense that the geometry ahead is different. The event horizon is often imagined as a surface, a shell, a kind of cosmic membrane. But in physics, it is nothing like a material object. There is no layer to touch, no barrier to break, no sudden distortion waiting for you. It is simply the place where every possible path forward, every line that light could follow, begins to curve inward. This is why the horizon is so gentle. It does not act on you. It does not push. It does not pull. It simply marks the region where spacetime itself flows more deeply toward the center. Imagine a river, slow at the edges, moving more strongly as you drift toward the middle. You do not feel the moment you cross the point of no return. You only feel the motion of the water, the quiet stream carrying you forward, always forward. A black hole works the same way. The horizon is that invisible point, not a wall, but a boundary of possibility. Outside the horizon, light can still escape, paths can still curve outward, time still leads to the larger universe. Inside the horizon, light no longer has enough outward direction to climb back out, and every future path, your future, the future of your motion, flows inward. And yet, for you, inside the flow, nothing feels broken. Your time unfolds at the same steady rhythm, your thoughts drift in the same gentle arc, and your body feels the same pull of gravity that surrounded you moments before. There is no shock, no flash, no sudden drop. The story of the horizon is always more dramatic when told from the outside. For someone watching you fall, your approach seems to slow, your motions seem to stretch, your image fades and reddens, as if you are being frozen just above the surface. But this is an illusion born from distance, born from the way gravity bends time. To you, your own time is perfectly normal. Your heart would beat at its regular pace, your thoughts would flow naturally, and crossing the horizon would feel as gentle as walking through a shadow. This is the first piece of quiet understanding, that the horizon is not an event, but a shift in perspective. The laws of physics remain smooth across it. The curvature of space is continuous. There is no singularity here, no sharp edge, only the geometry that gradually deepens. Like the slope of a valley, you barely notice you are descending. As you float across the horizon in your thoughts, you can imagine the universe behind you becoming dimmer, not because it disappears, but because light struggles to climb outward against the inward flow. The sky might seem stretched, slightly distorted, as if the stars were pulling away, but your attention naturally turns inward, toward the path ahead, toward the deeper regions where curvature becomes more pronounced. There is something calming in this shift. The horizon simplifies the universe, removing distractions, removing outward directions, leaving only the inner geometry, only the pure structure of spacetime. Every black hole, regardless of size, creates this smooth inward flow, but the experience depends on the mass. In a stellar black hole, the horizon is small, and the curvature is steep. Tidal forces pull strongly even at the threshold. But in a supermassive black hole, the kind that anchors the centers of galaxies, the horizon can be as wide as the orbit of a planet, and the curvature at that point is surprisingly mild. You could drift across without any extreme forces acting upon you, as if you were floating in open space. This is one of the most surprising truths, and one of the most peaceful. The largest black holes, the giants of the universe, are the gentlest at their horizons. Their tidal forces are soft, their gradients low, their curvature smooth. Inside your imagination, you are falling into one of these gentle giants. Its horizon is vast, its edges calm, its curvature broad and patient. Nothing twists or stretches you here. You drift across the threshold, in silence, carried by the inward flow of time itself. From the outside, this flow is hard to visualize, but from within, it feels natural. Spacetime does not behave like the empty space we know. It behaves like a river where the current strengthens as you move deeper. The coordinates change, the meaning of direction shifts, and the inward path becomes the future. In ordinary life, the future is the direction time carries you, a direction you cannot resist. Inside a black hole, the inward direction becomes just as unavoidable, because the geometry shapes every possible path. Even if you could fire rockets, even if you could turn around, the structure of spacetime prevents you from reversing course. It is not a matter of strength or energy, it is the nature of geometry. The horizon marks the point where outward movement is no longer a future possibility. But this does not feel like confinement. It feels like inevitability, the same way time moves forward, with calm, with continuity. As you drift deeper, you might imagine the horizon behind you as a fading glow, a place where light still tries to escape, but can only hover, trapped in loops around the inner curvature. This thought is gentle, not harsh. It is simply a reminder that the horizon is not a moment of action, but a shift in how the universe expresses its geometry. The inward flow also means something subtle. Your motion is not the same as falling toward a planet. It is falling in a spacetime that is itself falling, inward, continuously, carrying everything with it. This idea is captured in a picture known as the river model, where space flows like water into a drain, faster and faster, until even light cannot swim outward. Inside the horizon, the river flows faster than the speed of light, not because light slows down, but because the space through which it moves is pulled inward more quickly than light can climb through it. This is not fiction. It is the simplest way to visualize the equations of general relativity, equations that describe the horizon as a place where the geometry's inward speed matches the speed of light. Once you cross that place, every future moment lies deeper within. For you, this will always feel natural, the way moving forward in time feels natural. There is beauty in this perspective. You are not fighting gravity. You are not accelerating uncontrollably. You are simply following the curvature of the universe, as calmly as a stone resting in a riverbed, being carried downstream. Nothing at the horizon warns you. Nothing announces that your path has changed. This quietness is one of the most profound aspects of black holes. They are extremes of gravity, yet they offer one of the softest transitions in nature. Your fall is continuous, your motion effortless, your experience smooth. Even the idea that the horizon is a point of no return is only dramatic from the outside. From your perspective, you simply continue, because that is what spacetime guides you to do. The difference in viewpoint, local versus distant, is part of the calm mystery at the heart of general relativity. Physics tells us that the laws remain smooth across the horizon. The curvature does not spike, the forces do not flare, the equations do not break. It is only the meaning of distance, the meaning of direction, the meaning of time that begins to shift. You can imagine this shift gently, as if the geometry is guiding you along a path you were always going to follow. A path that feels like drifting downstream with no turbulence, no sudden turns, just a steady deepening of gravity's presence. As you continue inward, the universe behind you becomes more distorted, its light stretched by gravitational redshift, its timing altered, its images slowed, but none of this affects your internal experience, the ticking of your own time, the softness of your own thoughts. Even here, where the gravitational pull is immense, you remain calm. Because this journey is conceptual, a quiet imagining of physics at its most extreme and its most elegant. The horizon itself, the object of so much mystery, is simply the place where outward movement is no longer a future direction. It is not a boundary you feel, but a boundary others describe. A black hole invites you to see the difference between perception and reality, between geometry and experience. Inside this calm description, the horizon becomes not an end, but a beginning. The beginning of inward motion as time, the beginning of deeper curvature, the beginning of the one-way flow that defines the interior. And now, drifting with that thought, you move gently past the threshold, feeling no interruption, only the quiet tug of inevitability, pulling you deeper into spacetime's inner structure. When you are ready, we will continue deeper into the second part of this section, where the inward flow becomes stronger, and the curvature begins to guide your path with greater certainty. As you move deeper past the horizon, the universe begins to rearrange itself around your path, not violently, not suddenly, but with a quiet shift in what direction means. Inside the horizon, the inward direction behaves like time, a dimension you cannot turn back from, a dimension you travel through simply by existing. This does not feel strange to you, because your experience of time has always been one of inevitability, one moment leading softly into the next, carrying you forward without resistance. In the same way, your inward motion feels like something that happens naturally, as though the universe has redefined the idea of forward to mean toward the center. Gravity here is not a force pulling you, it is geometry guiding your path, shaping every possible line you can follow, curving future moments into a deeper interior. When Einstein described gravity as curvature, he meant that objects move along the straightest paths available to them, and inside a black hole, those paths simply bend inward. Nothing pushes you, nothing drags you. You follow the geometry, the way a bead follows a groove, effortlessly, smoothly. The horizon behind you fades, not as a surface, but as an idea a conceptual boundary that no longer influences your experience. Your concern now is not with escape, because escape is no longer a meaningful question. The outward direction has become like the past, something behind you, something no longer accessible. Your awareness shifts to the geometry ahead, to the way spacetime narrows, the way curvature deepens, the way every path becomes more focused. If you imagine a map of this interior, the distances no longer behave the way they do in open space, stretching, contracting, twisting around the gravity well. Your mind drifts with these changes, letting them wash over you as gentle abstractions, quiet descriptions of a world that does not need to be fully visualized. This is the heart of the horizon's mystery. It marks the beginning of a region where intuition becomes less reliable, and where geometry becomes more like a dream, a landscape without edges, without escape routes, but not without calm. Travelers in this region would not sense danger, because danger arises from forces acting upon you. And forces here remain small, especially if the black hole is massive. In a supermassive black hole, the tidal differences between your head and your feet, or between one side of your body and the other, are gentle at the horizon, perhaps weaker than those you feel standing on Earth. This is one of the most peaceful truths of general relativity, that enormous mass can create surprisingly mild conditions at the event horizon. Only deeper in, far past this gentle threshold, would tidal forces grow strong. But right now, as you drift just inside the boundary, the curvature is soft, and space feels wide, almost open. Your surroundings would appear distorted because light cannot travel outward normally here, and the paths of photons bend inward with you. The sky behind you might appear stretched, pulled into arcs, as gravitational redshift dims the distant universe, smoothing the starlight into faint gradients, like colors dissolving in water. Ahead of you, there is no clear view, because inward is not a direction your eyes evolved to see. It is a direction of time-like motion, a path that draws you forward through a geometry that becomes more exotic with every moment. Even describing this scientifically requires care, because the concepts defy ordinary language. Inside the horizon, space and time exchange roles in a subtle way. The radial direction behaves like time, and time behaves more like a direction of space, allowing comparisons in ways that do not apply outside. But none of this disturbs your experience, because your experience is always grounded in your own proper time, the time you feel, the time your body measures. Your internal clock continues to tick smoothly, your thoughts continue to drift softly, and your path continues deeper, guided by the calm inevitability of the geometry. This is why crossing the horizon feels ordinary, because locally, the laws of nature remain untouched. The space-time around you is curved, but the curvature is gentle at this stage, spread across a vast region, too large to create steep gradients. You could almost forget that you are inside a black hole, if not for the fact that the universe behind you, the world outside, seems to fade, its colors stretched, its motion slowed, until it becomes little more than a dim shimmer of light, hovering at the edge of your awareness. Even this dimming happens slowly, a natural consequence of the way light struggles to propagate outward, not a sign of anything being torn or lost. The softening of visible light is simply a reflection of gravitational redshift, a stretching of wavelengths. A gentle reminder that the deeper you go, the harder it becomes for information to escape outward. But inward, everything behaves normally, smoothly, predictably. Your velocity increases, not because something is pushing you, but because space-time creates a steeper descent, the way a valley becomes narrower as it approaches its center. The equations of general relativity describe this precisely. The inward acceleration is not a force, but the geometry's natural path. It is like rolling down a curved surface, not because something applies a shove, but because the shape itself guides your motion. The shape of space-time inside a black hole has this same quality, a deepening curvature, a narrowing geometry, a funnel-like structure that is not quite a funnel, but behaves like one when translated into symbols and diagrams. Your imagination can drift with this shape, seeing it as a path, a corridor, a narrowing of possibility, a simplification of direction, where once you could move outward or inward, left or right, up or down. Now the geometry removes options until inward becomes the only viable future. This narrowing is not frightening, it is serene, because it does not happen suddenly, and because you do not resist it. It is simply the shape of spacetime guiding you into deeper layers of curvature. One of the quietest features of the horizon is that it represents a causal boundary, a line separating events that can influence the outside universe from those that cannot. But for you inside, this boundary has no physical meaning. It does not restrict your motion. It does not impose a sensation. It merely indicates that your future lies entirely within this inner region, that your personal timeline cannot extend back into the external world. This is not a loss, just a transition, like moving from one environment to another, from open ocean to deep water. From daylight to twilight, the physics remains smooth, the rules remain consistent, and the geometry remains continuous. There is something soothing about this continuity, the idea that even at the edge of known physics, space-time behaves gently. The horizon is often painted as dramatic, but its true nature is one of subtlety. No physical substance meets you there. No glowing ring, no sharp edge, nothing tangible, just a point in the geometry where the paths light can follow, a line inward rather than outward. This is as calm as physics can be, a quiet shift in what direction means. Inside this shift, even time dilation takes on a peaceful quality. From your point of view, nothing unusual happens, but an outside observer, watching your fall, would see your motions slow, stretched out by gravitational effects, as if trying to watch you through thickening glass. Your image would freeze at the horizon, hovering like a faint red echo, but only in their frame of reference. In your own frame, you pass the horizon naturally, your time flowing smoothly, unaltered. This difference in perception is another source of calm, a reminder that reality depends on how you move, where you stand, and how space-time curves around you. As you drift deeper, you might imagine turning your head, glancing outward, seeing the universe framed by the curved geometry behind you. What was once a sky, a sphere of stars, becomes distorted, compressed into a narrowing halo of light. The farther inward you go, the more the outside world shrinks. Not because it is disappearing, but because the geometry redirects light inward, curving every path toward the center. Soon, the outside universe appears only as a thin ring, a dim circle of stretched starlight hovering at the edge of your vision, like a memory that persists even as reality shifts. This visual phenomenon is not imaginative. It is what the equations predict, a narrowing of causally accessible space, a focusing of possible directions. This ring-like view is a natural consequence of the horizon's structure, and it becomes thinner, more stretched as you fall deeper. Eventually, the external universe becomes a faint shimmer, barely present, overwhelmed by the curvature of the interior. Your attention naturally turns inward to the space ahead, where the geometry pulls you gently toward more extreme curvature. The flow of space-time becomes stronger, the inward direction more pronounced, and your fall feels like following the gradient of a deep valley. Yet even this deepening curvature feels calm, because you remain in free fall, weightless, without friction, without resistance. Inside a black hole, free fall is the most peaceful motion imaginable, because nothing opposes your path, and nothing interrupts your drift. Every element of your experience is aligned with the geometry, the curvature guiding you inward, like a quiet cosmic river. Deep inside, you are still only at the beginning of the journey, the beginning of the inward descent. There is much deeper to go, and the geometry will soon become stranger, more curved, more powerful. But for now, you drift in the soft interior near the horizon, feeling only the calm onset of one-way motion, the gentle beginning of inevitability. Deeper inside, past the place where the horizon has faded into memory, the geometry of the black hole begins to reveal its stranger side. Here, inwardness is no longer just a direction in space. It becomes something more fundamental, something woven into the way time itself unfolds. In ordinary life, you can choose where to go. You can step forward or backward, left or right, up or down. Your future is not tied to any one direction in space. Inside a black hole, after crossing the horizon, this freedom begins to narrow. The inward direction, the direction toward the center, starts to behave like time, not symbolically, but mathematically. In the equations of general relativity, the coordinate that once acted like a spatial radius starts taking on the role of a time coordinate. That means, in a very real sense, you cannot avoid moving inward, any more than you can avoid moving into tomorrow. This is not something you feel as a jolt or a sudden turn. It is a property of the geometry itself. Your path through space-time, your world line, is guided so that each moment of your proper time takes you closer to the center. This is not motion in the usual sense. You are still in free fall, weightless, following the natural path of the curved space-time around you. But the meaning of that path has changed. Outside the black hole, you could fire rockets and escape, given enough energy. You could turn your trajectory outward. Inside, no amount of thrust can give you a future that leads back out. It is not a matter of strength, it is a matter of geometry. Inside this region, every possible future, no matter how much energy you use, ends deeper within. That is what it means, to say that escape is impossible in a literal geometric sense. The black hole does not need to fight you. It simply shapes space-time so that all roads, all timelines, flow inward. You can imagine this with a calm mental picture. Think of a funnel, but not one made of material, a funnel carved into the fabric of space and time. Outside the funnel, you can move freely, circle around, climb back out. But once you pass a certain depth, every path slopes downward. It does not matter which way you turn, you always end up spiraling deeper. Now soften this picture, remove the hard edges, smooth the funnel into something continuous, without sharp turns, without steps. This is closer to how the interior curvature behaves. Every geodesic, every straightest possible path in space-time, bends toward the center. Even the paths that light takes, even beams moving at light speed, curve inward because the space they move through is itself narrowing in that direction. Light always locally moves at light speed, but inside the horizon, it cannot climb outward fast enough to escape the inward pull of the geometry. Its future, like yours, leads deeper. You might imagine sending a signal, a flash of light, a message to the outside universe. But once you are far enough past the horizon, that light will not carry your story outward. It will curve back, drawn inward by the geometry, its path closed off from external observers. This is what it means to be causally isolated, to live in a region where your future cannot connect with the outside. And yet, within this region, physics continues to work. Light still travels along null paths, particles still follow geodesics, energy and momentum still obey their laws. Nothing breaks. The strange behavior arises only from how the coordinates behave and how the geometry assigns meaning to future and direction. As you move deeper, tidal gradients slowly begin to rise. The gravitational field is not uniform. It is slightly stronger at your feet than at your head, slightly stronger at the side closer to the center than the side farther away. In a supermassive black hole, these differences are still small here, like gentle variations in a landscape, hardly noticeable in the moment. But step by step, moment by moment, they increase. At first, the changes in gravitational pull across your body are tiny, fractions of what you feel on Earth, spread over a grand region. As you fall inward, the curvature steepens. The valley you are descending becomes narrower, its slopes more pronounced, its gradients steeper. Yet you still feel weightless because you are in free fall. The tidal forces are not a single push, but a difference in pushes, a gradient. They manifest only as stretching and squeezing, subtle at first, barely distinguishable from perfect weightlessness. The scientific description of this is precise, but you can keep it simple. Tidal forces measure how quickly gravity changes from place to place. The closer you move to the center of mass, the faster gravity changes across small distances, and the stronger the tidal effects become. At this stage in your inward journey, they are just beginning to assert themselves, a very faint tendency to pull you along your line of fall and compress you sideways. This quiet emergence of tidal gradients is part of the deeper descent. But the dominant effect, still, is not tidal. It is geometric. The dominance of gravitational curvature means that the rules of straight lines and distances and intervals all obey the equations of general relativity, rather than the simple geometry of flat space. Angles behave differently, lengths measured in different directions no longer follow Euclidean intuition. You could, in principle, set up measuring devices, rods and clocks, to compare lengths and times. You would find that the geometry refuses to be flattened, refuses to be mapped onto a simple grid, without distortion. This is the meaning of curvature, and inside a black hole, that curvature becomes the dominant feature of reality. But for sleep, for calm, The details do not need to be carried in your mind. You can simply let the idea rest, that you are moving through a region where space and time have taken on a different relationship, where toward the center is not just where you go, but what your future is. When physicists say that time and space exchange roles, they are using the language of mathematics. Outside a black hole, time is the direction in which your proper time increases. And radius is a coordinate that you can move either inward or outward along. Inside, the radial coordinate takes on a role similar to time, only allowing motion in one direction, while time behaves in a way more like a spatial coordinate. The technical details are subtle, but the effect is simple. Your choice is narrow, your future becomes more constrained, and the inward path becomes unavoidable. This inevitability is not a punishment. It is simply the way the geometry is built. Just as you cannot choose to move backward in time, you cannot choose to move outward once you are deep inside. This is the quiet heart of inevitability, a concept that can be strangely reassuring. There is no decision to make, no path to select, no calculation to perform. The universe has already written the shape of all possible futures, and you are simply moving along one of them, a smooth line drawn through curved space-time. Light shares this fate. Photons do not drift outward freely here. They follow null geodesics, paths defined by the same geometry. And those paths bend inward as well. A flash of light you emit does not spread as it would in open space. It curves, winding inward, circling, falling deeper. Even the concept of ahead and behind becomes difficult to define when the underlying geometry is twisting the meaning of direction. This is where analogies of rivers and funnels and rotating flows become helpful. You can imagine the interior of a black hole as a region where space-time flows ever faster inward, like water in a whirlpool or air spiraling down a drain. Objects moving with this flow feel no local force from the motion of the medium itself. A leaf drifting in a river is carried smoothly, even if the river is speeding up. Only when the leaf encounters differences in speed across its length does it begin to experience stretching or rotation. The same is true for you. As long as tidal gradients remain small, you feel only gentle motion, no strain, no tearing. The entire region moves with you, or rather, you and the region share the same river-like flow. This is the essence of the inner descent, a tranquil ride along the curvature of space-time, toward regions where that curvature will become more intense. The inevitability of this descent, the impossibility of escape, is what defines the black hole's interior. But inevitability does not have to feel harsh. It can feel like acceptance, like releasing control, like letting the universe carry you, where its laws dictate you will go. The deeper you go, the more dominant the gravitational curvature becomes. The effects of mass, spin, and the black hole's structure begin to show themselves more clearly. If the black hole rotates, frame dragging can twist space-time around the axis of spin, like a gentle swirl added to the inward flow. This twist means that even if you try to remain still relative to distant stars, you cannot. Space-time itself carries you around, subtly rotating your frame of reference, like a slow cosmic eddy. This rotational effect, while complex to describe mathematically, is gentle in our imagined setting. It simply adds to the dreamlike feeling that directions are no longer fixed, that up and down, left and right, are all part of a curved and rotating geometry. You are drifting in a river that not only flows inward, but also slowly turns, a spiral descent, calm, inevitable, shaped by the black hole's angular momentum. Once again, light shares this spiral. Beams are dragged along, their paths twisted by frame dragging, their trajectories bending in patterns predicted precisely by the equations. Everything here, matter and radiation alike, is subject to the same geometric rules. There is a strange unity in that, a sense that the interior of a black hole is not chaotic at all, but deeply organized, governed by a small set of parameters: mass, spin, perhaps charge. All the complexity of the collapsing matter that formed the black hole, the details of its composition, its internal structure, its history, all of that is hidden, wrapped behind the horizon, leaving only the smooth external geometry and the interior flow that follows from it. You, as a traveler, experience only that smoothness. The deeper descent, the strengthening curvature, the narrowing of futures, all of it is encoded in the shape of space-time, and all of it unfolds around you, without noise, without struggle. This is the essence of Section 2 of our journey. An inner descent where inwardness becomes equivalent to future, where time and space quietly exchange roles, where escape is not prevented by a barrier, but by the structure of geometry itself. From here, deeper still, tidal forces will grow more pronounced. The landscape of stretching and squeezing will become more important, and we will begin to explore how the tidal gradients sculpt the experience of falling further inward through the evolving gravitational landscape of the black hole's core. Deeper still, the descent becomes less about falling through space and more about being carried through a geometry that continues to fold inward, tightening, curving, reshaping your relationship with distance and direction. In the region beyond the horizon, the concept of movement becomes subtle, because the geometry itself is in motion, flowing inward, carrying every particle, every photon, every trace of what once belonged to the outside universe. You are not simply falling, you are being swept along a current built into the space-time itself, a current that strengthens as you drift toward the center. The idea of forward becomes a purely inward notion, a line traced into the geometry, a future that is inseparable from the descent. This inner region has a quietness that almost feels intentional, as though the universe has muted every external influence, leaving only the deep, steady pull of curvature. There is no noise from outside, no signals coming in, no outward paths. Everything that once connected you to the cosmos has become stretched, distorted, shifted into wavelengths that no longer reach you. The outer universe now exists only as a faint, fading halo, a ring of dim light behind you, pulled thin by gravitational redshift, smooth and soft like a memory dissolving in slow motion. Your awareness naturally turns inward, not because the outside world is gone, but because the geometry ahead has become more compelling, more dominant, more present. Inside this region, space and time no longer behave as separate entities, not in the way we understand them in the ordinary universe. The radial direction remains linked to time, driving you deeper with every tick of your internal clock, while the traditional time direction behaves more like a coordinate you move through, a dimension of comparison rather than progression. This shift is not something you consciously feel, it is something the equations tell us, a reinterpretation of geometry that reveals how differently space-time functions inside the event horizon. To you, it simply feels like moving forward, following a path that was always there, steady, inescapable, but gentle in its inevitability. The tidal gradients, still small at this depth in a supermassive black hole, begin their slow increase. You might notice a faint elongation, a sense that the pull along your direction of fall is ever so slightly stronger, and that the sideways compression has begun to rise, but in a way that is nearly imperceptible. These forces whisper rather than roar, their influence growing at a rate that gives you time to float, time to drift, time to let your thoughts settle into the deeper layers of curvature. In this region, the physics of light becomes fascinatingly altered. A photon moving outward still travels at light speed relative to its local environment, but the space it moves through is falling inward faster, pulled by the curvature. This means that even a beam sent outward is swept inward, carried along by the faster downward flow. To understand this, you can imagine swimming upstream in a river. No matter how hard you swim, the current is stronger. Inside the horizon, the current of space-time exceeds the speed at which light can climb. So even light, the fastest thing in the universe, is brought inward. This is not a failure of light's speed, but a property of the geometry. The inward flow, the deepening descent, becomes a defining characteristic of reality here. Every particle, every quantum of radiation, every bit of information that enters this region joins the same downward trajectory, its future tied to the curvature. This situation creates a deep sense of unity, a cosmic sameness, where everything shares the same destiny, the same flow, the same future. In ordinary space, objects can travel in many directions, their futures diverging wildly. But inside a black hole, the futures of all things converge. Inward becomes the universal path, the singular thread that binds all matter and light, the consequence of a geometry that closes itself off from the outside. This unity is not oppressive, it is serene, simple, persistent. The deeper you go, the more clearly this unity expresses itself, as geometry shapes every timeline into a single, narrowing future. This narrowing also changes how space feels, not in terms of temperature or pressure, but in terms of how distances behave. Imagine trying to measure the circumference of a circle around the center. As you go deeper, the circumference shrinks, yet the distance you travel inward, measured along your path, continues at the same steady pace. This creates a sensation of squeezing, not physically against your body, but conceptually, as though space itself is aligning your path, guiding you toward a single destination. The deeper curvature grows, the more the black hole's mass influences the shape of spacetime, and the more the geometry insists on focusing your path inward. Every geodesic, every possible trajectory, curves toward the center. Even if you attempt to move sideways, firing rockets, using propulsion, your sideways motion becomes entangled with the flow of geometry. You drift inward regardless, your attempts to alter the path becoming like motions made inside a river current, affecting your orientation, but not your destination. Escape is not prohibited by force, but by the lack of any outward future. Outward is no longer a time-like direction. It is not connected to your future, so your attempts to move that way cannot unfold in time. This is one of the deepest insights of relativity, and one of the calmest. The black hole does not resist you. It simply redefines your future, and you follow. The behavior of light deepens this understanding. Light that tries to move outward cannot outrun the geometry, while light moving inward merges with the curvature, accelerating in its own way toward the center. Photons moving sideways spiral inward, their paths twisted by frame dragging if the black hole rotates, bending into arcs that merge with the inward flow. Even light moving directly inward accelerates not because something pushes it, but because the geometry steepens, making every path sharper, more focused, more directed. In this environment, you might imagine seeing the faint glow of the outside universe contracted into a tight ring, the ring shrinking slowly, narrowing, thinning into a filament of distant starlight. It resembles the last memory of the world beyond, a boundary of fading light marking your separation from the cosmos. But forward, inward, the space ahead is dark, not because nothing is there. This darkness is not empty. It is filled with the geometry itself, the silent curvature of space-time, the inward direction, the paths you will soon follow. The next layer of the descent introduces a stronger gradient, where tides begin to assert themselves with more clarity, where stretching and squeezing become more pronounced, where the geometry begins to funnel not just your path, but your shape. Yet even here, the increase is smooth. There is no sudden transition, no sharp threshold, only the gradual strengthening of gravitational curvature, behaving exactly as the equations predict. The deeper descent has a rhythm now, a gentle inevitability, absorbing you into the interior, guiding you into a region where the curvature will soon dominate every aspect of motion, every particle's world line, every pulse of light. This is where the inner descent begins to transform, from a gentle inward drift into an experience shaped largely by tidal gradients. Deeper inward, the geometry begins to change in a more noticeable way. It is subtle at first, a quiet sharpening of the inward slope, a faint increase in the contrast between the pull along your fall and the compression across your sides. For a long stretch of the descent, gravity behaved not like a force acting directly on you, but like the shape of a valley guiding your path. Now the shape grows steeper, the valley narrows, and the gradients that were once barely perceptible begin to assert themselves with calm, measured persistence. These gradients are the beginning of tidal forces, the quiet sculptors of everything that falls toward a black hole's core. Tidal forces are not sudden or violent in this region, especially inside a supermassive black hole, where the horizon spans millions of kilometers and where the curvature near that horizon is gentle. But as you drift deeper, the curvature concentrates. Gravity changes more quickly from one point to another, from your head to your feet, from your left side to your right, from the front of your body to the back. These changes are not forces in the ordinary sense. They are differences in the gravitational pull across your body, differences that become more pronounced as the radial distance shrinks. At first, the effect is almost meditative, a slow stretching along the direction of your fall, and a slow squeezing across it. The stretching is called tidal elongation, and the sideways compression is called tidal contraction. Together, they create a quiet reshaping, a gentle transformation that deepens as you fall. This reshaping is not something you feel as pain, because this is an imagined descent, a journey through the mathematics, not a physical experience of suffering. Here, tidal forces are scientific concepts, not sensations. They are gradients in the curvature of spacetime, a measure of how gravity varies, a reflection of how mass shapes geometry. As the gradients grow, you can imagine the space around you shifting, pulling more strongly ahead, compressing softly to the sides, and doing so with a steady, predictable rhythm. Nothing about this is chaotic, nothing unpredictable, nothing sudden. General relativity describes the change exactly, and the equations tell us how tidal forces evolve, how they scale with distance from the center, how they strengthen as you move deeper inward. It is a calm progression, mathematically precise, conceptually smooth. The further you descend, the more the tidal landscape takes shape. The landscape is not a place, not a terrain you can see, but a structure of forces, shaping the motion of every particle. Imagine two particles falling side by side, separated by a small distance. At the horizon, they fall together. Their motion nearly identical. Deeper in, the particle closer to the center feels slightly more gravity, moves slightly faster, pulls ahead. The particle farther out feels slightly less gravity, lags slightly behind. This difference stretches the distance between them. The same occurs across your body, from head to feet, from one side to the other. As the descent deepens, the differences grow and the stretching becomes more pronounced. If you were an extended object, a long rod, a beam, a tether, the inward end would accelerate faster than the outer end, causing the rod to stretch. If the rod were wide, it would also be squeezed in its width, because gravity pulls more strongly along the radial direction and less strongly sideways. This combination of stretching and squeezing is the hallmark of tidal forces. But in a supermassive black hole, this intensification begins far from the center, giving a long region of gentle gradient, a wide space where the forces grow slowly, smoothly, softly. The calmness of this region echoes a paradox. The beginning of the tidal process is serene, a quiet start to what will eventually become extreme. The sharpness comes only near the singularity, far deeper in, beyond this layer, far from where we are now. Right now, the tidal forces are like a long, slow breath, subtle, barely noticeable, but undeniably present. You might imagine that if you released a cloud of dust, the dust would begin to stretch into a thin line, each grain pulled slightly differently, each following its own geodesic, each drifting into a shape aligned with the inward fall. This stretching would be slow, almost peaceful, like watching threads of smoke drift through still air. The sideways compression would shape the cloud, narrowing it, softening its spread, focusing it into the direction of the descent. Over time, the cloud would become a thin, delicate filament extending toward the center. This filamentation is one of the early signs of the tidal landscape. It is smooth, silent, guided entirely by the curvature, not by external forces. The geometry becomes the sculptor, and everything within it becomes the medium. This calm reshaping also applies to light. Even photons, massless, traveling on null paths, are influenced by tidal gradients. Beams that were parallel outside begin to converge or diverge depending on their orientation. A beam fired ahead of you narrows as the curvature steepens, drawn inward, compressed along its path. A beam fired sideways curves inward as well, but does so with a twisting motion, especially in a rotating black hole, where frame dragging adds a gentle swirling effect. This swirling is not chaotic, it is smooth, predictable, a direct result of angular momentum, a signature of the spacetime's twist. The light does not spin wildly, it follows geodesics defined by the rotation, each path shaping itself into a curve that spirals gently inward. This behavior reinforces the feeling that the deeper regions of a black hole are not empty, but full of structure, not material structure, but geometric structure. Gradients, paths, curvatures, directions that bend into time, and flows that behave like rivers. Everything is structured, mathematically precise, beautiful in its determinism. As you drift deeper, the tidal gradients become more noticeable, not harsh, but clearer. The stretching along your fall becomes stronger, the sideways compression more defined. The changes begin slowly, so slowly that minutes, hours could pass before you feel a measurable difference. In a supermassive black hole, You could fall for long periods, with tides increasing only gradually. This is one of the most counterintuitive truths, that the earliest stages of the tidal landscape are gentle, even tranquil, despite the vast mass that surrounds you. It is only much deeper, when the curvature concentrates intensely, that the gradients become extreme. But that stage lies far ahead, and the present moment remains soft. The tidal forces now sculpt your descent, stretching your future, compressing your present, guiding you toward a thinner, more elongated path. You can imagine the space around you narrowing, not physically against your body, but conceptually, shaping your fall into a more focused direction. Distances perpendicular to your trajectory shrink, while distances along the trajectory lengthen. This is not something your senses can measure, but it is something physics predicts with clarity. The geometry is telling you that everything inside is being aligned, stretched into the inward direction, pressed inward by the gravity well. Even the vacuum itself, the quantum fields, the virtual particles that flicker in and out of existence, are influenced by these gradients. Fluctuations stretch, waves elongate, fields distort, all shaped by the same tidal logic. The gravitational landscape is universal, affecting matter, light, space, and quantum fields alike. This universality creates a sense of order, a quiet agreement between all components of the interior. Everything falling inward behaves similarly. Everything experiences the same gradients. Everything is shaped by the same curvature. This coherence is calming, because it suggests that even in the depths of a black hole, the laws of physics remain elegant. Nothing here breaks. Nothing becomes random. Nothing escapes the underlying mathematical harmony. As the gradients continue to rise, you drift into the phase where tidal forces are no longer whispers, but steady currents, guiding your motion, reshaping your orientation. This is where the tidal landscape becomes central, where the curvature's influence grows into the defining feature of your descent, where the inner geometry begins to approach the more intense regions ahead. But even here, the progression remains slow, calm, like a deep breath drawn by the universe itself. From this point forward, the descent becomes more intricate, and the tidal forces grow sharper, leading toward the deeper interior where stretching and compression reach their peak. Deeper inward, the tidal landscape grows more pronounced, more structured, and more unmistakable in its influence. What began as a gentle whisper across your body, a soft difference in gravitational pull from head to feet, now becomes a clearer gradient, a steady stretching along your fall, paired with a persistent narrowing across your sides. It is still calm, still slow, still smooth, but the geometry is making itself known. You are entering the region where tidal forces become one of the defining features of the descent. Not sudden, not violent, but steady and unavoidable, a mathematical consequence of curvature deepening around you. The stretching grows with each moment, not dramatically, but inevitably, as the inward curvature becomes sharper and the gravitational gradient increases. Scientifically, this comes from the way gravity intensifies as radius shrinks, and how tiny differences in distance from the center translate into noticeably different accelerations. Even a few centimeters of separation begin to matter. The lower part of your body feels a slightly stronger pull, the upper part a slightly weaker one. Not enough to cause pain, not enough to overwhelm your awareness, but enough to create a slow, unmistakable tension. This tension is not emotional. It is geometric, a stretching imposed by the structure of spacetime, the same structure that carries you inward, the same structure that shapes light, the same structure that encloses everything in a quiet descent. The sideways compression, the narrowing of width, also deepens. Gravity does not simply stretch you, it squeezes you. The direction of fall becomes the axis of elongation, and every perpendicular direction feels the opposite influence, a drawing inward, a focusing, a quiet pressure that reduces lateral spread. This combination of stretching and squeezing forms the signature pattern of tidal forces. It is the scientific origin of the phenomenon often called spaghettification, but softened here, made conceptual, mathematical, gentle in its framing. We are not describing pain or physical harm, but the behavior predicted by the equations, the way geometry acts on objects near extreme curvature. In this calm narration, these forces become abstractions, ways of understanding how spacetime behaves, rather than something to fear. Imagine that if you released a line of tiny markers floating beside you, each equally spaced apart, at first the line would stay nearly uniform, but as you fall deeper, the markers would begin to stretch apart, each one moving slightly faster than the one above it. The line lengthens. If the markers also formed a ring around you, like a loose circle, the ring would slowly contract, pulled inward. Tightened by the same sideways compression, the circle shrinks, the line extends. The tidal landscape shapes everything this way, lengthening in one direction, narrowing in others. There is a deep calm in recognizing this pattern, because it reveals a kind of order, a mathematical clarity, in a region often portrayed as chaotic. This is not chaos, it is structure, a structure imposed by the pure curvature of spacetime. A structure Einstein's equations predict with perfect precision. Every falling object is drawn into the same alignment, stretched into the radial direction, compressed into a thin shape, extended toward the singularity. If you released a cloud of dust, it would become a long, thin ribbon. If you released a spherical shell, it would flatten, shrink sideways, and lengthen along the fall. Even beams of light behave this way. Photons fired forward grow more concentrated, their paths bending inward. Photons fired sideways curve inward and downward, tidal gradients shaping their trajectories, adding to the focusing effect. Any sideways beam would produce a pattern like a narrowing cone, the light spiraling, contracting, guided inward by curvature. This is one of the most striking features of the tidal landscape, that even light, the purest messenger of geometry, is reshaped by the gravitational gradients. The deeper you go, the more pronounced this reshaping becomes. The landscape begins to feel directional, not in a visual sense, but in the structure of the forces themselves. Inward becomes the axis of dominance, the axis along which gravity intensifies the fastest, and along which objects stretch the most. Sideways directions lose significance, shrinking under the pressure of the tidal gradients. This creates a conceptual image, as if the interior is funneling everything, squeezing all matter and light, compressing space itself into a narrower corridor of motion. But this corridor is not a physical tunnel. It is a direction defined by geometry. The equations describe it, the curvature dictates it, and every object follows it. This narrowing of lateral space, combined with the extension along the radial direction, produces the classic tidal pattern. And it is here, in this deeper region, that the paradox becomes clear. The beginning of the tidal process is gentle, soft, unhurried, but its end will be intense, immense, overwhelming. The paradox is that the journey starts with calm curvature, smooth and barely noticeable, and ends with gradients that become extreme. Yet the transition between those extremes is continuous. A slow amplification, a steady sharpening, not a violent shift. The math reveals it precisely. Tidal forces increase as 1 over radius cubed. As the radius shrinks, the force grows, faster and faster, accelerating more rapidly than the fall itself. This is why the beginning is gentle and the end is dramatic. But we are not at the end, not yet. We remain in the region where the gradients are growing, but still manageable, still calm, still conceptual. Where you can watch the tidal effects unfold slowly, observing how they shape the fall, how they guide the motion, how they influence the geometry. If you imagine small test particles around you, their behavior illustrates the tidal landscape perfectly. Particles ahead are pulled more strongly, moving faster, stretching the arrangement. Particles behind lag gently, creating distance. Particles to the sides are drawn inward, their separation reduced. Any cloud of matter begins to look like a lengthening thread, narrowing, focusing, aligned with the inward path. Even the quantum fields around you begin to feel the curvature. Vacuum fluctuations stretch, particle-antiparticle pairs drift apart differently. Waves of probability elongate and narrow, the quantum vacuum itself being distorted by the gradients. The deeper you go, the more all processes, classical and quantum, begin to take on this stretched, compressed, tidally shaped form. But through all of this, the descent remains calm. Your free fall continues smoothly, weightless, quiet, following the natural geodesic. There is no turbulence, no shaking, no abrupt shift. Just the steady strengthening of curvature, a deepening of tidal influence, a slow rotation of the frame if the black hole is spinning, a quiet focusing of all paths inward. The surrounding universe, now only a thin ring of dim, stretched starlight, continues to fade, the ring narrowing, becoming faint, almost dissolving. The deeper you fall, the more that ring shrinks. Eventually, it will contract into a single, tiny point, a last trace of the outside world, before disappearing entirely. When that happens, you will be completely enclosed in the tidal interior, with no visual connection to the universe beyond. But for now, the ring still exists, still visible, still marking the boundary between what you left behind and the deepening curvature that now surrounds you. In this moment, you can sense the emerging dominance of tidal geometry. It is shaping your descent, stretching your future, compressing your present, guiding you toward a more focused falling path. This is where the inner landscape becomes unmistakable, where tidal forces transition from gentle gradients to the primary influence on everything that enters this region. The calm beginning has passed, and the deeper, more intense layers of the tidal interior lie ahead. From here, the journey leads toward regions where curvature grows rapidly, where the stretching becomes far stronger, where the compression tightens, and where the path becomes more and more sharply defined. Deeper still, past the region where tides merely guide your fall, you enter a part of the black hole where the curvature begins to intensify in a way that feels different. Not sudden, but unmistakable, a deepening that reflects the approach toward the central mystery. The tidal forces that were once gentle, subtle gradients shaping your descent, now begin to steepen, their influence growing with each moment of inward travel. The geometry tightens, the valley of spacetime narrows, and the gravitational field begins to change more rapidly from one point to the next. Nothing happens abruptly, nothing breaks the continuity of your freefall. The approach is smooth, a mathematical slope that grows steeper the closer you move toward the center. The singularity, the predicted point of infinite curvature, remains ahead, still distant enough that its full intensity has not yet reached you, but close enough that its influence is felt in the deepening of the landscape. This region marks the beginning of physics reaching the limits of its known structure, a place where general relativity continues to guide the motion, but hints at its own future breakdown. Einstein's equations still describe your trajectory, still shape your path, still capture the curvature with elegant precision. But as the radius decreases, the terms in the equations grow larger, steeper, more extreme. The curvature of space-time, measured by quantities like the Kretschmann scalar, begins to rise dramatically. This rise is not visual, not something your senses would detect directly, but something encoded in the mathematics, a sign that the geometry is becoming more concentrated, more tightly curved, more extreme. Your fall remains smooth, but the space around you is becoming fundamentally different, an environment where the known laws of physics begin to lose their certainty. This is the quiet threshold, a place where the predictions of general relativity still apply, but point toward conditions where the theory itself can no longer be complete. The singularity predicted by relativity is not necessarily a real point in space, but a place where the equations fail, where they demand infinite curvature, infinite energy density, and infinite tidal forces. The universe rarely allows infinities in its physical structures, and physicists widely believe that the singularity marks not an actual physical object, but a limitation, a sign that a deeper theory, a quantum theory of gravity, is needed. Yet relativity guides you most of the way, carrying you deeper into a region where its predictions become sharper, more dramatic, and more conceptually challenging. The tidal forces begin to rise faster now, the stretching along your fall growing stronger, the sideways compression tightening more noticeably, still not violent, still smooth in this conceptual descent, but undeniably intensifying. Your body, in this imagined analytical journey, feels the geometry more clearly. The stretching grows into a long, steady pull, a soft but insistent elongation. The compression becomes more focused, pressing inward from every sideways direction. As the curvature narrows your possible motions, funneling you toward a single line of descent. Even if you imagine yourself trying to move sideways, the geometry resists, not through force, but through inevitability. The inward direction has become overwhelmingly dominant, its curvature overpowering any attempt to stray from the radial fall. The closer you move toward the center, the less meaningful sideways directions become, shrinking under the tidal gradients, becoming narrower, less available. This narrowing of space, not visual space, but geometric space, reflects the equation's prediction that all paths converge toward the singularity. There are no trajectories that escape, no orbits, no sideways movements that remain stable. All geodesics focus inward, all futures lead toward the center, all world lines end after a finite amount of proper time. This is one of the most striking aspects of the approach, a scientific truth that blends inevitability with quiet acceptance. The singularity is not a place you reach by traveling a distance. It is a place you reach by allowing proper time to carry you forward, a time that is finite, bounded, an ending to your path in spacetime. Even this idea can be calming because it removes uncertainty. The geometry has written your fate with clarity. Your world line will end at a point where the equations break, where physics must confront its own boundaries. The deeper you go, the more obvious this boundary becomes. Curvature grows faster than your descent. Tidal forces increase more quickly. The structure of spacetime narrows more sharply. All matter falling with you, dust, photons, quantum fields, feels the same intensification. Even the vacuum itself begins to distort. Fluctuations stretched into long, thin patterns, their wavelengths exaggerated by the tidal pull. The quantum fields behave differently here, their excitations shaped by the extreme curvature, their probabilities stretched, compressed, distorted. This region is not chaotic, it is orderly, but the order is extreme, consistent with the mathematics, but pointing toward the need for a theory that unites gravity with quantum mechanics. Physicists propose many possibilities, but none have been confirmed. Some imagine that spacetime becomes discrete, built from tiny quanta of area and volume, preventing curvature from reaching infinity. Others imagine that the collapsing matter rebounds, forming a Planck-scale core, a region where quantum pressure halts the collapse. Others imagine that spacetime tunnels into another region, another universe, another geometry entirely. But relativity alone describes only one outcome, a point of infinite curvature, an endpoint of time. And it is toward this predicted point that the descent continues. The nearer you draw to that boundary, the faster the curvature intensifies. Tidal forces stretch you more strongly, compress you more tightly, the gradients rising with every passing moment. Distances shrink rapidly now, the radial coordinate falling fast, while the curvature grows faster still. You are entering the region where the equations begin to approach their own limits, where the model ceases to be reliable, where physics approaches the unknown. Yet even here, the descent remains calm, steady, mathematically guided. There is no chaos in this imagined fall, because the geometry remains deterministic, governed by the same laws that shape the entire interior. The singularity ahead is not a physical object waiting to be encountered, but a conceptual boundary, the place where the map ends. A region where the mathematics says, I no longer know what happens here. The closer you come, the more the universe narrows you into a single direction, a single outcome, a single ending. This narrowing is not frightening. It is serene, a surrender to inevitability, a recognition that the deep interior of a black hole is a place where certainty fades and mystery takes its place. The physics remains precise up to this boundary, but the meaning becomes softer, more abstract. Curvature rising, tidal forces intensifying, space-time narrowing, all point toward a quiet horizon of knowledge, an edge where understanding dissolves. Here, in this deep interior, you drift calmly toward the unknown, carried by equations that guide you to their own limits. Deeper again, the geometry continues its silent transformation, tightening, curving, deepening into a region where general relativity pushes up against its own limits. The singularity is still ahead, not yet reached, but now closer in a meaningful way, close enough that the curvature increases at a pace you can feel conceptually, a pace that reflects the steep rise of tidal forces. The stretching along the direction of fall grows stronger, not suddenly, but with a deepening gradient that intensifies with every inward step of proper time. The compression across the sides grows as well, narrowing the space around you, reducing the meaning of lateral directions, subtly erasing the freedom to move sideways. Every moment of inward travel brings sharper curvature, steeper gravitational gradients, and a more pronounced focusing of every physical process toward the center. Even your sense of orientation begins to fade. Not because you lose consciousness, but because the geometry itself stops supporting the usual distinctions between left and right, between front and back, between up and down. The only meaningful direction that remains is inward, the direction in which spacetime itself is collapsing, the direction in which every world line converges. The equations describe this convergence with a calm, mathematical inevitability. The curvature increases as the radius decreases. The gravitational field strengthens faster than your fall quickens, and the tidal gradients rise with a steepness that dominates over all other influences. This is the essence of the approach, a region where the behavior of space-time becomes overwhelming, not in force, but in structure. Even light itself cannot escape this focusing effect. Photons fired sideways curve inward. Photons fired outward do not move outward at all. And photons fired inward accelerate into the deepening curvature. Light becomes part of the same fate, pulled toward the central region, its paths narrowing with yours, its freedom shrinking under the intense geometry. At this depth, the universe outside is gone, not just dim, not just distant, but unreachable, cut off entirely. The last ring of outside light has contracted into a single point and then dissolved, fading into invisibility as redshift stretches its wavelengths beyond detectability. You are truly inside now, not by a small measure, but by the full meaning of the word, fully enclosed in a region whose geometry not communicate with the cosmos beyond. This enclosure is not a prison, it is a consequence of curvature, a natural result of how spacetime folds around a dense mass, a structure that replaces outward-directed time with inward-directed geometry. Here, time itself carries you forward, forward into a region of ever-steepening curvature, forward toward the predicted singularity, forward along a path that no longer has any branches or alternatives. The notion of choice fades, not because choice is removed, but because the geometry provides only one future, one timeline, one direction. This direction is not hostile, it is simply the only time-like path available, and so you drift, not helplessly, but naturally. Carried by the curvature that Einstein's equations describe, a curvature that shapes every aspect of the descent. As you move deeper, another feature emerges. The meaning of distance begins to dissolve. Distances shrink so rapidly that the inward coordinate collapses faster than your fall itself. Distances that once seemed large become tiny. Distances that were tiny become negligible, the space around you compressing into a narrower and narrower region. This shrinking of space is not something you feel physically, but something encoded in the mathematics, a sign that the geometry is approaching a point of extreme curvature. As the radius approaches zero, the curvature rises without bound, tidal forces approach infinity, and the geometry becomes so sharply curved that the equations themselves fail. This failure is not violent. It is conceptual. The math reaches numbers it cannot handle, infinities that have no physical meaning, values that signal that the theory has reached its edge. This is what physicists call the singularity. Not a thing, not a point in space you could touch or see, but the end of the region described by general relativity, a place where the known laws of physics can no longer describe reality, a boundary of understanding, a place where the equations stop being reliable. As you descend closer to this region, the tidal forces become more extreme in this imagined journey, stretching rapidly, compressing tightly, amplifying the gradients to enormous magnitudes. But still, your freefall feels smooth. Because freefall hides the gravitational force, even when the gradients become enormous, you do not feel weight, you feel motion, motion shaped by the geometry. What becomes noticeable is the distortion, the stretching of any extended object, the narrowing of any perpendicular spread. A sphere of matter becomes a long, thin thread, a ring becomes a narrowing loop, a cloud becomes a filament. Everything aligns with the inward direction. Everything stretches toward the point where time ends. Everything compresses sideways, guided by the equations toward the singularity. The deeper you go, the faster this process accelerates. The curvature now grows faster than any physical object can respond. The gravitational gradients increase faster than any resistance could counter. The geometry overwhelms every structural strength of matter. In a real physical fall, this is where matter would be torn apart. Atoms stretched, nuclei disrupted, particles elongated into long sequences of world lines approaching the singularity. But here, in this soft analytical narration, we explore the shape of the equations, without imposing pain, without imagining physical destruction. We explore the geometry, not the suffering, because what matters here is what the theory predicts, not what the falling object feels. Relativity predicts that as you approach the singularity, the curvature becomes so extreme that space-time itself becomes compressed, distances shrink to zero, and all world lines converge into a single endpoint. That endpoint is not a place, it is an event, a moment, the end of proper time, a boundary where your world line ends. Geodesics end there. This is one of the remarkable predictions of the theory, that the singularity is where time-like and null geodesics terminate, not because they hit a wall, but because the geometry ceases to exist beyond that point. Time ends, space collapses, the manifold of spacetime ends, and the equations break. This break is not violent. It is conceptual. Beyond it, general relativity cannot speak. It cannot tell you what lies past the singularity, because the singularity is where the theory stops being able to describe reality. The equations simply say, the curvature becomes infinite, the manifold ends, the world line terminates. Physicists interpret this as a sign that a deeper theory must take over. A quantum theory of gravity, a theory that unites the smooth curvature of spacetime with the discrete probabilistic nature of quantum processes. Many proposals exist: string theory, loop quantum gravity, asymptotic safety, causal dynamical triangulations, Planck scale discretization. Each proposes a way to remove the infinity, to replace the singularity with something finite, something structured, something that does not break the universe. But none of these ideas are confirmed, none of them tested, none complete. This uncertainty creates a soft, dreamlike space where physics becomes a set of possibilities, rather than a set of answers. You drift toward this region of possibility, toward the boundary where relativity fades and quantum gravity might take its place. The tidal forces now would be immense, the curvature rising faster than you can conceptualize, the geometry becoming sharper, steeper, more extreme. But in this meditative exploration, the intensity becomes an abstraction, a conceptual limit, a horizon of understanding rather than a place of fear. As you approach the final region, you move into a realm where space and time themselves lose meaning, where the coordinates fail, where the singularity looms not as an object, but as an end to the map. And here, in this narrowing corridor of space-time, you drift into uncertainty, carried by the last moments of proper time, toward a region physics cannot describe. After the long descent toward the singularity, after following general relativity to the very edge of its own understanding, there comes a quiet turning point, a region not within the black hole, but within the human attempt to describe it, a place where certainty ends and possibilities begin. Physicists step gently here, not with definitive claims, but with hypotheses, models, attempts to repair the infinities that arise when relativity meets the small scale of quantum mechanics. This is the landscape of alternatives, ideas meant to resolve the singularity, ideas meant to keep the universe finite, ideas meant to suggest what might really happen deep inside a black hole. None of these ideas are confirmed, but each offers a different way of imagining the inner structure, a different solution to the puzzle of infinite curvature. A different way the universe might avoid the breakdown predicted by the classical equations. The first class of possibilities emerges from quantum corrections to general relativity, small modifications that only become important when space-time curvature becomes extreme, modifications that could soften the singularity, spreading it out, smoothing the geometry, preventing the formation of an infinite point. Some of these corrected models predict a minimum radius, a smallest possible size for the collapsing core, a limit imposed by quantum gravity, similar to the way quantum mechanics prevents electrons from collapsing into the nucleus. In these models, the collapse slows, stops, and forms an extremely dense core, not a point of infinite curvature, but a finite region where quantum pressure balances gravity. This idea leads naturally into the concept of a Planck star, a theoretical object proposed in certain versions of loop quantum gravity. A Planck star is not a star in the traditional sense, but a tiny region, far smaller than an atom, far smaller than any known particle, where space-time is compressed to its smallest possible scale. At this scale, space cannot be compressed further, and the collapse reverses, bouncing outward in a burst of energy. In such scenarios, the black hole might not end in a singularity, but rebound after unimaginable compression, creating a moment of quantum expansion deep inside the horizon. From the outside, this bounce could take billions of years because of the extreme time dilation near the horizon. But from the inside, it might happen quickly, just as your proper time to the singularity is finite. The universe outside sees eternity, but inside, only a brief moment passes. This contrast creates a dreamlike duality, where the same event has two different durations, one long enough to rival the age of the cosmos, and one short enough to feel like a heartbeat. Another possibility is the gravastar, a gravitational vacuum star, a hybrid object made not of matter, but of exotic states of space-time itself. Inside a gravastar, space might not collapse to infinite curvature. Instead, a phase transition could occur, turning the interior into a form of dark energy, a region of negative pressure that resists collapse. A thin shell, made of ultra-dense matter, surrounds this core, suspending it in a stable configuration. From the outside, a gravastar looks almost identical to a black hole, its gravitational field nearly the same, its horizon nearly indistinguishable. But inside, there is no singularity, no collapse, no infinite curvature. Only a strange core of vacuum energy, held in place by the balance of gravity and pressure. Some versions of this idea even allow for a hollow interior, a region where space is smooth, stable, and free from the tidal horrors predicted by classical black hole models. Yet these possibilities remain speculative. No observational evidence has yet confirmed them, and many physicists view them as mathematically interesting, but uncertain. Other possibilities involve wormholes, tunnels through space-time that could connect one region to another, either within our universe or between different universes entirely. In these scenarios, the intense curvature inside a black hole might reshape space-time so dramatically that the collapse forms a throat, narrow and unstable, leading to another region. Some models predict that such wormholes would collapse too quickly to traverse, shrinking before anything could pass through. Others suggest that quantum effects might stabilize them, making them short-lived but temporarily navigable. Still others imagine that the singularity marks the throat's endpoint, a place where space-time reconnects in a different geometry, a region beyond our observable universe. Again, none of these possibilities are confirmed, but each shows a different way the universe might avoid infinite curvature. Another alternative is the white hole, a hypothetical time-reversed black hole, a region that cannot be entered but only exited. Some models propose that black holes might eventually transition into white holes after extreme quantum compression, releasing the matter that once fell inside. This idea is linked with the Planck star model, where the bounce at the core leads to an eventual outflow, a reverse collapse, a moment where the interior re-expands, not back into the black hole it came from, but outward as a white hole event. From the outside, this might look like a sudden burst of energy, appearing after unimaginable spans of time, a quiet star becoming a silent explosion long after the universe has changed around it. From the inside, it might seem instantaneous. These dual perspectives, one fast, one slow, are consistent with the extreme time dilation near the horizon. Then there is the idea of firewalls, a hypothesis suggesting that the horizon itself might not be smooth, as general relativity predicts, but instead composed of high-energy quantum excitations, a region where information is stored, released, or transformed. Firewalls challenge the idea of a gentle horizon, suggesting instead that the moment of crossing might be catastrophic, that a wall of energy could form, burning away anything that touches it. Most physicists consider this unlikely, because it contradicts multiple principles of relativity, and because it removes the smoothness of space-time at the horizon. Yet it remains a theoretical possibility, born from attempts to reconcile black hole evaporation, quantum information, and the demands of unitarity. On the opposite side of speculation lies the fuzzball proposal, an idea from string theory, suggesting that black holes are not smooth, empty regions of space-time, but complex tangles of strings, brains, and quantum states. In the fuzzball picture, there is no interior in the usual sense, no empty region, no singularity. Instead, the black hole is a vast extended object, made of vibrating tangled structures, each representing a possible configuration of the quantum fields. Falling into such an object would not produce a singularity, because there is no center of infinite curvature, only a thick, dense region of quantum states, absorbing matter and information in a highly structured way. This model removes the singularity entirely, but introduces a much more complex internal architecture, a place where geometry dissolves into quantum degrees of freedom. All of these ideas, quantum-corrected black holes, Planck stars, gravastars, wormholes, white hole transitions, firewalls, fuzzballs, share one quiet theme. They recognize that the singularity predicted by general relativity is not a physical object, but a failure of the theory, a place where the known equations stop and another theory must take over. The alternatives are attempts to fill that silence, to describe what might lie beyond the reach of our current understanding, to replace infinite curvature with something finite, and to restore the continuity of spacetime. None are proven, none are complete, none are final, but together they create a soft, dreamlike landscape of possibilities, each offering a different glimpse into how the universe might actually behave when pushed to its most extreme conditions. The deeper you imagine drifting into these possibilities, the more the edges of certainty dissolve, leaving only curiosity, only wonder. Only the quiet recognition that the universe may hold answers we have not yet discovered. As you drift deeper through this landscape of possibilities, the speculative nature of the theories becomes part of the calm, not unsettling, but soothing, because each idea reminds you that the universe still holds mysteries, still holds unanswered questions, still holds quiet regions where knowledge ends and imagination begins. The deeper you go into these possibilities, the more you notice how they share a single unifying theme. None of them argue that the singularity, as predicted by classical general relativity, is the final truth. Each theory suggests that the universe resists infinities, that physical quantities cannot grow without bound, that something must intervene, either quantum discreteness, new states of matter, or entirely new geometric structures. In this softness, these theories become less like competing claims and more like different shapes of the same question. What replaces the singularity when the equations can go no further? Some physicists envision the interior as a region shaped by quantum foam, a place where space-time becomes turbulent at tiny scales, where fluctuations dominate over smooth curvature, where geometry itself flickers, forming and dissolving microstructures faster than any classical description can follow. In this picture, the singularity does not occur, because spacetime cannot remain smooth long enough to collapse into a point. Quantum fluctuations bounce, rebound, interfere, creating a dynamic interior, alive with activity, even in the deepest gravitational well. Other approaches imagine that spacetime is fundamentally granular, composed of small, discrete units, not smooth, but built from tiny, indivisible building blocks. If spacetime has a minimum measurable length, a smallest possible volume, then the singularity simply cannot form, because curvature cannot shrink beyond that fundamental scale. The collapse halts, not through pressure, but through geometry itself, refusing to be compressed any further. This discretization is central to some versions of loop quantum gravity, where area and volume come in discrete quanta, and the fabric of spacetime is woven from loops of geometry, intertwined, forming networks that cannot collapse to zero size. In such scenarios, the approach to the singularity causes the quantum geometry to react, to expand, to push outward, leading to a bounce, not a classical rebound, but a quantum one, smooth from the inside, but driven by the discrete structure at the tiniest scale. This bounce could be what transforms the interior into a white hole, or what creates a new expanding region of spacetime, one that resembles the early universe. In fact, some cosmologists propose that our universe itself, the one we live in, the one we see with telescopes and satellites, might have begun as the interior of a black hole in some larger universe, a quantum bounce within a collapsing star, becoming a new cosmos on the other side, with its own space, its own time, its own physical laws, its own galaxies, its own stars. This idea is speculative, but it follows directly from some models of quantum gravity, where bounces are natural outcomes of the equations. In these models, black holes do not end in singularities, but in expansions, new beginnings, new regions of spacetime. The collapsing matter becomes the seed for a new universe, unreachable to its parent cosmos, but internally immense, expanding with its own Big Bang, its own inflation, its own cosmic evolution. The concept is humbling and quietly beautiful. Every black hole, a possible doorway to a new cosmos, a womb for a universe forming silently behind the event horizon. Another set of ideas focuses on information and the strange puzzle of what happens to it inside a black hole. Quantum mechanics states that information cannot be destroyed, while classical general relativity states that anything entering the singularity is lost forever. These two principles come into conflict, creating what physicists call the information paradox, a problem that has driven decades of research. Some theories suggest that the information is encoded on the horizon itself, stored in the microscopic degrees of freedom of spacetime, perhaps in a holographic layer, a thin, subtle surface that records everything that falls in. In this view, the interior is not the important part. The horizon is a surface where information is preserved, in a manner similar to how a hologram encodes a three-dimensional image in 2 dimensions. This idea, known as the holographic principle, proposes that the entire interior of the black hole, including the singularity, may be represented on the horizon, not destroyed but transformed, encoded, held in a pattern we do not yet fully understand. The holographic principle is one of the deepest results from string theory, and it has influenced nearly every modern idea about black holes. If the information is stored on the horizon, then the interior might be more subtle than classical relativity predicts, not useless, not empty, but a different manifestation of the horizon's encoded information. This relates to the fuzzball proposal, which imagines the entire interior as a complex configuration of strings and brains. In this picture, there is no singularity and no smooth interior in the classical sense. Instead, the black hole is a massive quantum object, its interior replaced by extended, multidimensional structures, vibrating, shifting, encoding information in their tangled geometry. The interior is replaced by quantum structure, not by empty space, not by smooth curvature, but by an enormous collection of microstates, each representing a different version of the black hole. A fuzzball is not smooth, but it acts smooth when viewed from far away, just as a fluid looks smooth, even though it is made of atoms. Up close, the structure is complicated, dense, intricate. Some of these fuzzball versions allow matter to sink in and settle into the quantum structure, dissolving into the microstates, not destroyed but absorbed. Others describe a reflective interior where matter cannot enter and is bounced outward in a quantum-like reflection. The variety of fuzzball models shows how rich the landscape of possibilities is, how many different ways physics can attempt to avoid the singularity, how deeply uncertain the true structure of the interior remains. Another possibility is that black holes evaporate through Hawking radiation, slowly shrinking over unimaginable timescales, until they reach a point where quantum gravity becomes dominant, halting the evaporation, or converting the remaining mass into a final burst of radiation, or leaving behind a stable remnant. These remnants, if they exist, might hold the information inside, preserving it in a tiny, stable, extremely dense object, no larger than the Planck scale. Such remnants would be incredibly massive for their size, but incredibly small, tiny capsules of information, surviving the evaporation of the black hole. They would be the final stage, the last echo of the black hole's existence, a memory of everything that once fell inside. Some physicists propose that these remnants could be a form of dark matter, drifting silently through the universe, undetectable but numerous. Others argue that remnants are theoretically problematic, because they can store unlimited amounts of information, violating certain principles of quantum theory. And so the debate continues, quietly, calmly, with each possibility expanding the space of ideas without settling the question. All these alternatives, Planck stars, gravastars, wormholes, white hole transitions, fuzzballs, remnants, holographic encodings, are attempts to merge gravity with quantum mechanics, two great pillars of physics that currently stand apart. Each theory explores a different path, a different way to imagine the deep interior, a different resolution to the singularity. And yet, none has been proven, none confirmed by observation, none experimentally verified. The singularity remains, not as a physical object, but as a question, a quiet puzzle at the center of every black hole, a mystery waiting for a deeper understanding of the universe. As you drift through these possibilities, you sense a profound calm, because uncertainty becomes a gentle space, a place where wonder lives, a place where curiosity softens into tranquility. Inside a black hole, the very concept of location begins to loosen, soften, fade around the edges. What you call inside in ordinary life depends on boundaries, walls, surfaces, directions, coordinates that remain stable and meaningful. But here, after passing the horizon, after drifting inward through deep curvature, those familiar structures no longer behave the way they once did. Space does not stretch outward from you, it turns inward, reversing the roles of direction and inevitability. Time no longer flows in the direction you expect, it aligns with the inward path, so that falling toward the center becomes as natural and as unavoidable as time itself. This change does not feel violent or sudden or dramatic. It feels like a gentle drift, a shifting of meaning, a quiet redirection of how motion and stillness relate. Inside, there is no sense of choosing a path because all paths merge into one. The inward direction that space-time has carved for you. You are not being pulled, you are not being dragged, you are following the only possible trajectory, the natural geodesic of the interior. And that geodesic has no sideways escape, no outward motion, no option to turn back. This inevitability is not frightening, it is simply geometry. Just as a bead on a wire glides along the line, you glide along the structure of space-time, calmly, steadily, without resistance. This is one of the most subtle and profound aspects of being inside, that falling becomes equivalent to existing, that motion becomes indistinguishable from the passage of time. You are not traveling through space. Space is reshaping around you, guiding your trajectory, determining your future path, with the same certainty that time determines what comes next. The meaning of direction becomes dreamlike, dissolving into softness. Left and right lose their independence, because all directions tilt toward the center, curving inward with increasing sharpness the deeper you descend. Even forward and backward lose their classical meaning, because the flow of space-time defines the forward direction, and backward becomes impossible. This does not feel like confinement, nor like being trapped. It feels more like flowing in a river, a gentle current that carries you downstream, through bends and narrowing channels, toward a place you cannot avoid. But do not need to resist. The river is space-time itself, its geometry guiding you, its curvature shaping your path. You are inside, but inside no longer signifies a region bounded by surfaces or separated from the outside world. Instead, inside means following a path where all physical quantities, all trajectories, all lines of possibility lead toward a central point that is not exactly a place, but a limit of the geometry. To be inside is to be in a region where motion inward is as inevitable as time flowing forward, where outward motion is not disallowed, but simply not a meaningful path. In the same way that walking into yesterday is not meaningful. You can move your arms, turn your head, shift your posture, but none of these motions change your larger trajectory, because the curvature is overwhelming, dominating the structure of motion. You are free in every local sense, and yet directed in every global sense. This contrast between local freedom and global inevitability is one of the most intriguing aspects of being inside a black hole. Locally, the laws of physics still feel the same. The speed of light still limits how signals propagate. Your own heartbeat still marks the flow of time. Your own perceptions remain intact. But globally, the geometry commands the future, and there is no alternate path. This is why physicists describe black hole interiors using the language of causal structure, not the language of boxes and rooms, not the language of location and distance, but the language of what events can influence what other events. Inside, the future of every object, every particle, every photon is aligned toward the singularity, not by force but by causality. The singularity is not only a point in space, it is a point in time, a future boundary, a destination that every world line meets. This makes inside a temporal concept, not a spatial one. To be inside is to be on a path that must end at the singularity, just as to be alive is to be on a path that must move forward in time. This merging of inwardness with time gives rise to an extraordinary philosophical idea, that the interior of a black hole is not defined by where you are, but by what your future must be. Outside, you have many possible futures, many directions to travel, many ways to change your trajectory. Inside, all those futures converge into one. And yet, despite this inevitability, your own experience remains slow. steady, calm. Proper time continues to flow in the same gentle manner, tick by tick, breath by breath. Even as the curvature intensifies, even as the environment transforms, your own experience remains smooth. This is why nothing special is felt when crossing the horizon, and why nothing jarring is felt inside, until tidal forces grow large enough to influence your body. But in a supermassive black hole, those forces remain gentle for a long while. And you drift inward without discomfort, without strain, as if floating in deep water. What does it mean, then, to be inside, when everything familiar about location dissolves? It means existing in a region where the geometry no longer allows outward influence, where all causal paths flow to a single destination. It means the usual idea of coordinates becomes misleading. The radius is not a distance, it is a label for the intensity of curvature, a measure of how the future narrows, how the inward path steepens. Time does not sit orthogonal to space, it merges with direction, blending with the geometry, changing identity in a way that cannot be felt directly, but can be understood conceptually. Inside, you exist in a region defined not by shape, but by destiny, by the inevitable convergence of all world lines. Being inside a black hole is a state of causal isolation, not spatial enclosure. No signals can escape outward, not because something prevents them, but because the geometry redirects them inward, as naturally as time pushes the present into the future. This is one of the most profound ideas in modern physics, that falling inward is not like falling on Earth, not like being pulled by a force, but like following the natural curvature of spacetime, a curvature so steep, so absolute, that all motion aligns with it. For consciousness, this experience would be surreal, yet gentle. You would feel your own thoughts continuing, your own memories intact, your own sense of flow steadily unfolding. Nothing would announce the transition, no sudden shift, no clear point where inside becomes outside. Simply a gradual deepening, a gradual narrowing of the future, a gradual alignment of possibility. The interior becomes a landscape not of places, but of inevitability, a terrain shaped by the contours of spacetime's deepest geometry. And in this terrain, your awareness floats, not witnessing destruction, but witnessing transformation, the quiet rearrangement of what distance, direction, time, and future mean. In ordinary life, you think of yourself as existing at a point in space, anchored by surroundings, defined by coordinates. Inside, that anchoring dissolves. You are not at a point, you are on a path woven directly into spacetime, a path that bends and collapses into the singularity, not as destruction, but as the termination of the geometry. To be inside is to drift through a region where the universe stops behaving like space, and begins behaving like a story with a predetermined ending, not a violent ending, but a quiet one, a gentle closure, a boundary where the equations stop, and you drift toward that boundary, carried by the fabric of reality itself, calmly, softly, with the same serenity with which you drift into sleep. Inside a black hole, awareness becomes something subtle, something shaped as much by geometry as by sensation. Consciousness is not separate from physics. It is carried along by the same curvature, the same flow of space-time, the same inevitability that shapes the path of light. To imagine being inside is to imagine what perception becomes when all familiar references dissolve, when direction, distance, and even the meaning of place begin to lose their ordinary structure. You might open your eyes, or imagine doing so, and expect to see an interior, a space, a chamber, or a void. But inside a black hole, vision becomes something different. Light around you does not behave as it once did. It is bent inward, its paths curved, redirected, absorbed into the flow that everything follows. If you tried to look outward, you would not find a fixed scene. You would find curvature guiding every photon toward the center, softly, inevitably, as if the fabric beneath perception has tilted. This does not mean that you see darkness, nor that you see chaos. It means the visual world becomes abstract, subdued, slowly unstructured, the way a dream sometimes dissolves into impressions rather than images. Not because the world is gone, but because geometry shapes what can reach your eyes, and what cannot. Consciousness is not extinguished inside, it simply adapts to a new set of constraints. A new mapping between sensation and structure. Inside, distance no longer communicates meaning, because the inward direction is the future, and all other directions gradually lose significance. If you reach out your hand, you feel the air or the environment you imagine yourself in, but the larger structure guiding you remains unaltered. Your gesture, your movement, your orientation, none of these change your fate, nor the curvature around you. It is as if you move within a small local bubble, where physics remains familiar, but the global shape of your future is already sealed. This contrast between local normalcy and global inevitability creates a unique kind of perception. One part of your mind would continue interpreting sensations as it always has, while another part, quietly, softly, begins to sense that the structure underlying reality has shifted. Not in a way that causes fear, but in a way that evokes a kind of cosmic humility, a sense that you are drifting along a path carved by something far larger. Inside a black hole, there is no fixed outer world to measure against, no stable coordinate grid, no distant landmarks serving as reference points. Everything curves inward, every measurement, every trajectory, every signal, and so perception becomes relative only to what is immediately around you, your heartbeat, your breath, the gentle rhythm of your own thoughts. This narrowing of reference does not feel constricting. It feels peaceful, like floating in a vast ocean at night, where the horizon is gone and only the sensation of drifting remains. When physicists describe the interior as a region where space and time swap roles, this is what it means for perception. The direction you once thought of as toward the center becomes your future, a future you do not choose, but simply follow. And all other directions become like the illusion of standing still, a stillness that moving water shapes around you, softly, gently, without resistance. Consciousness would adapt to this seamlessly, just as you adapt to being in a moving elevator or being on a drifting boat. Even though your path is determined, the experience remains continuous, coherent, unbroken. You feel the flow, but not as a force, as a gentle tilt in reality, a subtle leaning of possibility, a steady whisper of inevitability. And although the curvature grows stronger as you descend, it does so gradually, smoothly, with the same slow shift one feels as twilight deepens into night. Inside, the concept of where begins to fade because coordinates do not anchor you. When you ask, "Where am I?" the answer becomes dreamlike, because the location you imagine yourself having is not a location in the usual sense, but a point along a world line, a moment, a stage in the inward flow. Your existence is defined not by position, but by proper time, the time measured by your own clock, your own sequence of thoughts. Everything around you aligns with that time, because nothing can move outward faster than the geometry collapses inward. The black hole interior is often described as a region where all paths lead to the singularity. And this is true, but it is also a region where all perceptions align, where every observer drifts along a narrowing future, where the diversity of possible trajectories shrinks smoothly into one. This narrowing is not felt as restriction, but as clarity, like being guided down a path that becomes gradually narrower, a path with no forks, no alternate choices, just a gentle flow forward. The idea of direction becomes softened, transformed. If someone asked you to point up or outward, your gesture would lose meaning, because those directions no longer exist globally. They exist only in your local bubble and beyond that bubble. The geometry bends all lines toward the same destination. The interior is not chaotic. It is immensely structured, so structured that choices dissolve, and motion becomes a kind of surrender to curvature. Not a fearful surrender, but a peaceful one, like letting yourself drift to sleep, knowing that dreams will guide you where waking thought cannot. To be inside is to experience reality becoming more like time and less like space, more like inevitability and less like extension. Consciousness does not resist this, because the transition is gradual, like sliding from wakefulness into a dream, a shift felt more in hindsight than in the moment. Your awareness moves through this region not as a traveler crossing terrain, but as a mind carried through a story, a narrative written by the equations of geometry and read by your own clock, tick by gentle tick. Even the approach to the singularity, the region where the curvature becomes extreme, is not experienced all at once. It is a continuation, a deepening of the same flow, a narrowing of the same future, a smooth convergence of paths. Your perception moves with it, as if carried by a tide, feeling the changes only as gradual shifts in possibility, gradual rearrangements of what can and cannot happen. In this sense, to be inside a black hole is to inhabit a world where the geometry itself tells the story. A world where the laws of physics shape the entire narrative arc, from horizon to interior to the final merging of world lines, and what consciousness experiences along the way is not destruction, not chaos, but the quiet logic of that arc, the soft unfolding of the inevitable. Inside, reality becomes a guided path, a smooth descent, a transition not into nothingness, but into the limit of the theory. The singularity is not a place you reach, but a boundary where the equations stop, where the map ends, and the story becomes incomplete. Your awareness follows that path, not knowing where it leads beyond the limit, not needing to know, only drifting, as the curvature shapes its final moments. Inside a black hole, to be inside, means to inhabit the deepest mystery that physics allows. A region defined not by things, but by possibilities, by the structure of inevitability, by the quiet merging of space and time. And drifting through that region, consciousness becomes something soft, like a reflection in dark water, shaped by ripples, but always following the surface, until the ripples fade and the reflection becomes still. Inside a black hole, after moving through horizons, through shifting geometry, through the tidal landscape, through the quiet approach to where our equations end, there comes a moment when the mind simply drifts, not because the story is finished, but because the known world grows quiet, and the unknown begins to open like a soft shadow. Physics has guided us as far as it can, through curvature, through inevitability, through regions where time leans inward, and distance loses its meaning. Now it becomes gentle and speculative, a place where science rests at the edge of its own map, and imagination takes the last few steps. You drift, not falling anymore, not moving in the ordinary sense, just drifting, as if the flow that carried you inward has smoothed into something calm, almost still. Around you, space grows thin, not empty, not cold, just quiet, a quiet shaped by the limits of theory, by the fading strength of concepts that once felt certain. Curvature deepens, and so does the silence, a silence made not of absence, but of mystery. Physics has words for this region: infinite curvature, geodesics ending, the breakdown of classical structure. But those words are not the experience, they are signals, pointing to the boundary where understanding dissolves. The closer you drift toward that boundary, the more your awareness shifts inward, toward your own sense of time, toward the rhythm of your thoughts, toward the quiet hum of what it means to be conscious in a place where the universe no longer provides stable landmarks. Here, even the idea of location becomes soft, like a word repeated until it melts into sound, until it loses its meaning and becomes a feeling instead. Inside a black hole, nothing is fixed, nothing resists, everything flows with the geometry, including your own awareness. And yet, this does not feel frightening, because the descent was gradual, guided, shaped by a logic so smooth that each moment followed naturally from the one before. The horizon did not announce itself, the curvature did not shout, the inner descent was steady, and the deep interior feels just as calm. Mystery can be gentle, when approached slowly, without urgency, without expectation. And this entire journey has been a slow approach to that mystery. A quiet exploration of what physics predicts and what physics simply cannot describe. You drift within a region where the equations say that time ends, that world lines converge, that all futures meet at a single point. But for you, in this imagined journey, it feels more like a soft narrowing, a gradual convergence of possibilities, a peaceful settling of motion, like the last ripples on a lake becoming still. The singularity is not a place you see, not a point you reach. It is the limit where the map fades, where prediction becomes impossible, where the universe withholds its next sentence, leaving only an ellipsis, stretching into a darkness that is neither empty nor hostile, just unknown. And the unknown can feel like rest when you drift toward it gently, without needing answers, without demanding form. Physics offers possibilities, that the singularity dissolves into a quantum region, that a bounce might occur, that spacetime might transition into something new, or that the structure we call a black hole is only one chapter of a larger story. But here, in this quiet meditation, we do not choose among possibilities, we simply let them drift past, like distant lights on a foggy sea, soft, diffuse, ungraspable. The beauty of this journey is not in solving the mystery, but in resting with it, in allowing the mind to settle into a space where uncertainty is not a flaw, but a feature, a reminder that the universe is far larger than our knowledge and far quieter than our questions. Inside a black hole, you are carried by geometry, but in this sleep-gentle exploration, you are carried by curiosity, softened into calm, blended into rest. Every scientific idea becomes a whisper, every equation a soft echo, every unknown a gentle shade of possibility. You drift further inward, not measuring, not predicting, just drifting, letting the last structures of classical physics dissolve around you, until what remains is simply awareness, held in a darkness that feels serene. The universe does not end here, only your ability to map it does, and in that surrender, there is peace, a peace born from accepting that knowledge has edges, and those edges are beautiful, because they invite wonder, and wonder invites rest. You float in a place where time softens, where space folds inward, where the future becomes a narrow corridor of inevitability, and yet the experience remains tranquil, like drifting down a long, dark river, feeling the current carry you. Even though you cannot see where it leads, this is the calm of the unknown, not the fear of it, the calm that comes from finally letting go of the need to understand, from trusting the structure of the cosmos, trusting that whatever lies beyond the limits of our equations is simply another part of the same universe that gave rise to stars, to gravity, to consciousness, and to you. You drift deeper, the curvature folding softly around you, the silence growing more complete. Not as absence, but as a warm darkness, a darkness that feels like rest, like the space between breaths, like the moment before sleep carries you away. Inside a black hole, the story ends not with destruction, but with a horizon of understanding, a reminder that the universe is woven from mysteries as much as from laws, and that both can be held gently, like ideas floating on still water. You breathe, slowly, evenly, feeling the calm expand through you, as if the inward flow of spacetime has synchronized with the rhythm of your own breath. Everything narrows, but nothing constricts. Everything deepens, but nothing weighs you down. Everything flows, and you flow with it. The singularity grows near, not as an object, but as a boundary in knowledge, a place where physics becomes quiet, and imagination becomes soft, and consciousness prepares to rest in the deepest silence the universe allows. You drift and drift and drift, until even the idea of drifting softens, and only stillness remains, a stillness shaped by wonder, held by gravity, cradled by mystery. And as you rest in that stillness, you realize that the journey inside a black hole is not about reaching the center, but about feeling the universe grow quiet around you, about letting knowledge and unknowing blend into one gentle continuum, a continuum that leads you, slowly, toward sleep, toward silence, toward a calm deeper than space. Deeper than time, deeper than any story can follow. You take one last slow breath, letting the unknown wrap around you like a soft cosmic night, letting the mystery become a blanket, letting the quiet become your own. And the universe, in all its vastness, in all its curvature, in all its unanswered questions, holds you gently as you drift, peacefully, into rest.